Hello, everyone. I hope you had a good break. Today I'm going to be working through one problem from this set of six that sort of asks the same questions about a series of different functions. And then I'll be posting the other five as a homework assignment today. These offer a kind of good opportunity to look at some of the facets of these problems involving rates of change in a relatively simple context to start with. So hopefully you guys will find this useful. So problems 1 through 6 ask you to look at a series of functions and assume that they're basically position versus time functions. And then they ask a few different things. They want you to find the velocity as a function of time. They want you to find the velocity at a specific time. They want you to find when the particle's at rest. They want you to find when it's moving in a positive direction. They want you to find the total distance that it travels in a certain amount of time. And they want you to draw a motion diagram. So all that stuff was covered in the reading I posted, but it's probably a lot easier to see it done step by step. So why don't we take a look at question 2 or equation 2 and see if we can work through it. So equation 2 is f of t equals t cubed minus 9t squared plus 15t plus 10. Okay, so it's a cubic function, and it's given as f of t. Remember that you can also write this as s of t. It's really just a notational difference, but get used to seeing s as a representative of position. So s of t equals t cubed minus 9t squared plus 15t plus 10. So the first question is to find the velocity at time t, which basically just means find the first derivative. So remember that the first derivative of a position versus time function is going to be a velocity versus time function. Remember that velocity is just change in position over change in time. So you can think of it as sort of ds over dt, or the first derivative. So we can write this either as f prime of t or s prime of t, or just v of t. And it's going to be the first derivative, so we just apply the power rule, and we get 3t squared minus 18t plus 15. And then the 10 just goes away because it's a constant term, so its derivative is 0. So that's just your answer to question A. The velocity as a function of time is 3t squared minus 18t plus 15. Part B, they want to know what the velocity is after 3 seconds. So all you have to do for that is plug 3 in for v. So we plug 3 in there, so v of 3. And that's going to equal, we have, let's see, we'll have 3, and then we have 3 squared minus 18 times 3 plus 15. So here we have 27 minus 54, so that's negative 27 plus 15. That gives us negative 12. And so you might be asking negative 12 what? And the answer to that is feet per second. So they tell you here that t is measured in seconds and s is measured in feet. So our velocity is going to be in units of 12 feet per second. And they want to know in question C, or part C, when the particle's at rest. So in order to find when the particle's at rest, what it means for a particle to be at rest is that the velocity equals 0. So more or less we want to find the zeros of the first derivative. So we can just set that equal to 0. We can say 3t squared minus 18t plus 15 equals 0. Very conveniently, all of these terms are divisible by 3. We can just divide by 3, and when we divide by 3 on this side, 0 divided by 3 is still 0. So we'll have t squared minus 6t plus 5 equals 0, and then we can just factor it. So we'll have t, and notice we have minus in the middle and plus here. It's going to be 2 minuses. So t minus 1 and t minus 5. You can see if we multiply it back out, we'll get positive 5, and we'll get minus t minus 5t minus 6t. This means that when t equals 1 second and when t equals 5 seconds, velocity is 0, so the particle is at rest. Part D, they want to know when the particle is moving in a positive direction. So this kind of all depends on the geometry of this parabola. So the function for velocity, v of t, is a quadratic, so its graph is going to look like a parabola. This sort of all hinges on, when is it going to open up or open down? And because our leading term is positive, we know that it's going to open up. If we see here, we have two zeros. We have a 0 at 1 and we have a 0 at 5. So we can do a kind of quick sketch. This won't be accurate, of course, but if this is our time axis and this is our velocity axis, our velocity is 0 when t equals 1, 2, 3, 4, and 5. So it's a parabola that opens up. That means that as we go far to the left or far to the right, it's going to point up. So we're going to have some little kind of trough in here, okay? So what that means is the velocity is negative here, but anywhere outside of this little trough created by the zeros, it's going to be positive. Of course, the positive velocity to the left of the v-axis doesn't really mean anything because it's occurring at negative time. But we can say that in this little window here from t equals 0 seconds to 1 second, we have positive velocity. And then from t equals 5 seconds on, we have positive velocity. Okay, so we can say velocity is positive for, and you can write this a number of different ways, but for t between 0 and 1 and t greater than 5. Okay. Now, part E is a little bit tricky. They want to know the total distance traveled. And, you might be saying to yourself, well, how could you figure out the total distance? You might be tempted at first. So they want the total distance in the first 8 seconds. You might be tempted to just find what the position is at 8 seconds and what the position is at 0 seconds and subtract them. That would give you the displacement of the particle, but not the total distance traveled. So remember, especially for those of you who take or have taken physics, the displacement of an object is how far it winds up moving from its original position. The distance traveled by an object is kind of all of the distance covered by it, even if it winds up kind of doubling back on itself. So they're different in that way. So to find the total distance rather than the total displacement, we want to look at the sort of different intervals where the particle has positive and negative velocity. So remember, we had negative velocity from 1 second to 5 seconds, but we had positive velocity outside of that window. So here's 5 seconds, here's 8 seconds. So what we want to do is kind of break the motion of the particle into 3 different windows. We want to look at, because it has positive velocity from 0 seconds to 1 second, then we know that if we look at the distance or its position here and its position here and subtract them, we'll get the actual distance that's been covered. Same thing here, because the velocity is negative this whole interval. If we look at starting position and ending position, we can come up with total distance. And here, if we look at this window where the velocity is all positive again, we can find the total distance covered. Now, we're not going to delve entirely into this yet, but what you're actually doing when you calculate this is finding, believe it or not, these little areas here, okay? And it kind of makes sense from a geometric standpoint, right? Because here we have a t-axis and a v-axis. So we have these little kind of irregular shapes that on one side have a dimension of time and on the other side have a dimension of velocity, or feet per second. So if you multiply them together, you'll get units of feet or distance. So you're basically, this calculation finds these little areas. And then to get the total distance, we add those areas up. Again, don't worry about the geometry of it. It's just kind of an interesting thing. So the way that we do this mechanically is we look at our position function. Okay, s of t equals t cubed minus 9t squared plus 15t plus 10. Okay, and we're looking at these three intervals. So from t is between 0 and 1, we're looking at t between 1 and 5, and finally we're looking at t between 5 and 8, okay? So what we do is we take the absolute value, because we're not concerned about if it's moving in a positive or negative direction. We want to know the total distance covered. We take the absolute value first of s of 1 minus s of 0, okay? And we're going to add that to the absolute value of s of 5 minus s of 1. And then we're finally going to add that to the absolute value of s of 8 minus s of 5, okay? The reason it's absolute values, again, is because we're not concerned with, here it's moving a negative distance, here and here it's moving a positive distance. We're just concerned with the total number of feet that have been covered, whether they were in the positive or in the negative direction. And the reason we can use these endpoints is because on these intervals, the velocity is either all positive or all negative. So you're not going to get any kind of distortions that way either. The way we'll do this, so s of 1, if you plug 1 in, you get 17. If you plug 0 in, you get 10. So this is going to be absolute value of 17 minus 10. Here, if you plug 5 in, into this, you get negative 15. If you plug 1 in, again, you get 17. So we have negative 15 minus 17. And then here, if we plug 8 in, you get 66. And if you plug 5 in, you get negative 15. So we're going to have 66 minus negative 15. So basically 66 plus 15. So we have more or less, we have 7 feet, 32 feet, and 81 feet. That gives us a total of 120 feet, okay? It doesn't mean that the particle is at any point 120 feet from the starting position. It just means that in those first 8 seconds, it's covered 120 feet of ground altogether, okay? So that is part E. And finally, part F, they want you to draw a little diagram kind of showing the motion of the particle. And we can use our answers from part E as kind of a guide for this. So let's say that this is 0 feet here. Okay, it's just going to be a one-dimensional axis showing position. So that's 0 feet here. Let's go by 10. So we'll have 10, 20, 30, 40, 50, 60, 70. It's not drawn to scale, obviously. And we'll do -10, -20, -30. Okay. So looking at our answers here, remember when t equals 0, we're at 10 feet. Okay, so we can put a little dot here and maybe say t equals 0 next to that dot. So for the first second, we move in the positive direction, and we wind up at about 17 feet. So we'll go just a little bit shy of this 20 here, and then we're going to turn around, okay? And we go all the way back to -15 feet. So that's in that next interval from 1 second to 5 seconds. So maybe we'll put here t equals 1. So we'll go all the way back right here to about -15. This is a t equals 5. Okay. And then we loop around again. And finally, we wind up at 66 feet. So just about here. Can put a little mark there and say this is t equals 8. Okay. So this is the general trajectory of the object. It starts at 10. It starts moving to the right a little bit, then it curves around and moves to the left for a few seconds, and then it curves around and starts moving much more quickly because it covers much more ground in that 3 seconds than it did in this first 5 seconds. And it starts moving in the positive direction and keeps going in the positive direction. So hopefully this is helpful. The other 5 problems, it's the same basic procedure, just different equations. So give those a shot and feel free to ask if you have any questions.